Okay, continuing from our integration, we looked at integration of e to the x, really straightforward. Integration of ln x, though, is a different kettle of fish altogether. So first things first, let's look what happens when we, integration involving ln x, I should say, rather than of. Y equals ln x, the differential is 1 over x. So I can now integrate it. If you remember from year 12, x to the power minus 1 was the only general power of x that I can't integrate normally, because when I add 1 to the power and divide the new power divided by 0, it doesn't mean it can't be done, as we're just about to see, because integration being the opposite of differentiation, I can differentiate ln to get 1 over x, I can integrate 1 over x to get ln of mod of x, because remember we can't do log of a negative value, so if this number is negative we've got to do mod of it. Similarly, when I'm looking at log of a function of x, its differential using the chain rule is f dashed divided by f. So the integral of this function, f dashed over f, is log of the mod of the function plus c. So when we're looking at fractional expressions, what we need to look for is the top a constant multiple of the difference at the bottom. If it's got other powers of x in, then this isn't our method. We're also not looking at this method unless the function on the bottom can be written to the power 1. If it's a bracket squared, then it's not a ln function. If it's a rooted expression, it's not a ln function. So it's only really when we can write the function on the bottom to the power 1. So let's have a look at a few examples and a few places that people make errors. If my integral is 4 over x dx, in this case it's a bit trivial, but I think it's a good thing to do, particularly for the second one and for other things, to always rewrite your potential log answered questions where the top is the exact difference to the bottom, and take out your constant out the front like this. So I can now say it's 4 ln mod x plus c. Particularly for this one here, the common wrong answer here involves ln of 4x, which isn't correct, I'm afraid. What you have to remember with this expression here, the quarter can be written out the front, and it's a quarter times 1 over x, and that becomes a quarter ln mod x plus c. It's nothing to do with ln 4x at all. If you try to differentiate ln 4x, you'd get 1 over x. You get 4 over 4x, 1 over x. And so in this case here, that's the common place people make mistakes for that particular question. And similarly, if I've got an integration to do with limits, 1 over 3x, I'd write 1 over 3 outside, I'll put my limits 4 and 32 there, and then 1 over x inside, dx. So I'd end up with a third, and mod x, I don't really need the mods because I've got positive numbers, 32 and 4, so I've got a third, and then ln 32 minus ln 4, rules of logs, ln of 32 over 4, which is ln 8. See the lines all over the place there, ln 32 over 4, which is ln 8. And then a third ln 8 is ln of 8 to the power third, which is ln 2. Because cube root of 8 is 2. Okay, so let's have a look at a few more. Similar sort of thing here, where the limits are actually in terms of e. As before, what would I do? I'd take the 2 out the front, write it as 1 over x dx. It takes, I don't know how long that took, 5 seconds. But it means, particularly for example 2, ones like that, people are going to make fewer mistakes, and you'll see for other things later on. So I get 2 ln mod x between e to the power 10 and e, so it's 2 ln of e to the 10, and then ln of e, 1, and so 10 minus 1, 9 times 2, 18. So to show that question, and that was the show that there. Example 5 wants us to do a substitution. In reality, we don't necessarily have to do a substitution because I can do it by inspection. I can tell that the top is the exact differential at the bottom. I know the answer will involve ln of mod of x squared minus 6, and then put my values in and so on and so forth. I've got to be careful because we've done substitution of indefinite integrals, but not ones involving limits. Let's have a look at the slight twist involving limits then. I can differentiate it, as before, du equals 2x dx, which is what I've got on top, but also I can stick in x equals 0 there, u equals minus 6. What I don't have to do if I do this, you see, is substitute back to get everything in terms of x at the end. I can just put these limits in and I'm good to go. X equals minus 2, u equals 4 minus 6, which is still minus 2. So my integral becomes, because remember that's x is 0 to x is 0, x is minus 2 to x is 0, becomes minus 2 to minus 6, 2x dx is going to be 1 du, and then 1 over u, x squared minus 6. So it's going to be ln mod u between minus 6 and minus 2, so it's going to be ln 6 minus ln 2, which is ln 3. 6 over 2 is 3. Okay. We've got 4 ones to do. It says by inspection. Now I'm going to actually rewrite 6c and 6d, and I'll show you why. It's just a matter of sorting the contents out. So I'm always looking. Remember I said it's as long as the expression at the bottom is to the power 1. Is the top the exact differential at the bottom? Yes it is. So I can just say that's f dashed over f. I've got ln mod x cubed plus 5 plus c. Is the top the exact differential at the bottom? Yes, because the differential of each of the 3x is 3. Each of the 3x. So I can say it's ln mod e to the 3x minus 8 plus c. This isn't exact, but we're only out by a constant. The differential at the bottom is 2x, so it's not a bad idea to write it as 6 times the integral 2x over x squared plus 3. Do you have to do this? No, but it does cut out potential errors. And then mod x squared plus 3. Slight difference in how I've written it. Notice I haven't bothered with the mods there. X squared plus 3, never negative, so I can just put brackets there. There's always the possibility because of x cubed, or because of the minus there, that these expressions could be negative. And here we have this one. Is that the exact difference at the bottom? No, it's not, especially with minuses around. I'm getting quite nervous. I want to rewrite it as something times, well, the difference at the bottom is 5x to the 4. What needs to go out the front to give me that minus 30? Minus 6. Solve out the x to the 5 over 7, so I've rewritten it like that. So it becomes minus 6 ln mod x to the 5 plus 7 and then plus c. Okay, so that's how we do inspection. I would really recommend doing that to make sure you've got your constant correct at that stage there. Okay, this last example here asks us, this is now a more typical A-level question, asks us for the area of the curve, techniques that we've seen in year 12, but obviously with this function here involving this power of x that we couldn't do in year 12, but we can now do. So the first thing we need to do, I need to find the points P and Q where the curve crosses the x-axis. So we need to solve y equals 0. I need to solve therefore 7 minus 3x minus 2 over x equals nothing. Times everything by x. Move it all across, so I've got 3x squared minus 7x plus 2 equals 0. Hopefully it factorises. I think we're good to go there. Let's have a check. I've got 3x squared minus 6x minus 7x plus 2. So x equals a third is my lower limit, and x equals 2 is my upper limit. So my area is the integral, because it's all above the curve, above the x-axis anyway, so it's the integral between the lower limit of a third and the upper limit of 2 of y dx. So I can integrate term by term, just as I was doing in year 12. Integral of 7 is 7x, minus 3x squared over 2, and now minus 2 ln, I can just write x because I'm putting positive values of x in. 2 and 1/3. So sticking 2, 14, minus 3 times 4, 12 over 2, 6, minus 2 ln 2, and then sticking a third in, so I get minus 7 over 3 plus, oh gosh, 3 over 9 and then divided by 2, so 3 over 18, which is plus 1 over 6, and then plus 2 ln of a third. And I can tidy this up a little bit. Horrible fractions. I've got 14 minus 6, 8. I can write minus 2 ln 2. I can write that as minus 2 ln 3. And I've got minus 14 over 6 plus 1 minus 13 over 6. So I can put those over 6 now. I've got 48 minus 13, 35 over 6, and then minus 2 ln log 2 plus log 3 ln 6. And that's in that form there, or 35 over 6 minus ln of 6 squared, 36. Either form is okay, I would think. It depends there. The question did ask for it to 3SF, so I'll be pressing buttons and doing something point, something, like that. So it'd be a calculator answer at the end. So it's always worth checking the question to make sure that you've answered it in the form that they want.